In this video, we're presented with a velocity time graph, and then we're given a bunch of options about how we could describe what's happening in the graph. We're asked to select every correct description from the list. So before I even look at the options, let's go through the velocity time graph and see if we can understand it. The vertical units here are meters per second. And at the starting moment when t is equal to 0, some object is moving at -3 meters per second. You can think of that as 3 meters per second to the left. Then 1 second later, the object is only moving 2 meters per second to the left. Then only 1 meter per second to the left. In other words, it's slowing down as it's moving leftward. At t equals 3 seconds, it becomes stationary. V is equal to 0 there. Now it begins moving in the rightward direction, slow at first, 1 meter per second, 2 meters per second, 3 meters per second. So to summarize here, we're looking at the graph for an object that starts out moving fast to the left. It then gradually slows down until it stops, and then it turns around and speeds up to the right. So which of these descriptions are accurate? The object turns around, yeah. And the turning point on a VT graph is always at that intersection with the t-axis where v is equal to 0. How about the acceleration? The acceleration is constant. Remember, the acceleration is the slope on a VT graph. The slope of this line is never changing, so that's true as well. You can have a constant acceleration with an object turning around. The classic example of this you can see in everyday life is if you throw an object straight up in the air. Gravity induces a constant acceleration downward, and the object is going to slow down and turn around and speed up in the downward direction. The acceleration never changes. C, the object is always moving in the same direction. No, we already know that it turns around. If you confuse this graph with a position time graph instead of a velocity time graph, then you would have a graph of an object always moving in the same direction. The total displacement is 0. Remember, the displacement is given by the signed area under the velocity time graph. While the object is moving to the left, the displacement counts as negative. When the object is moving to the right, the displacement counts as positive. And by symmetry, those two delta x's, those two displacements, are going to have the same magnitude, but this one counts as negative. When you add up the total displacements, you get 0, so that is true. Part E, the object is always speeding up. That's not true. We already figured out the object is slowing down at the beginning and speeding up at the end. If you find the physics content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce over 100 new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.